Hello, ladies and gentlemen. Welcome back to another lesson in 8th grade math. Today we are going to learn about our second linear equation. All right, our second linear equation. And it's one of the other most popular ways to see a linear equation. Here's what I want you to do. Okay, for slope-intercept form, we have just spent all of 4.3 A, B, and C on slope-intercept form. We are going to need to know that later. We're going to actively be using both of these linear equations, okay? So I need you to remember that, but I need you to put that in something kind of like a box in your mind. You can have that as an open box. Yes, I know, I'm an artist, okay? An open box. And right now I'm going to need you to kind of close that box and just push it off to the side. Okay, you need to guard and save that information for later. But right now I need you to open up a new box because this is completely different. It has similarities because it's a linear equation, but it's completely different. So I need you kind of, for the moment, to close off what you know about slope-intercept form and open up a new box. Open up your, believe it or not, that's your brain. Open up your brain and say, I'm ready for this new information because these two don't overlap except for in one small way. So I need you guys kind of ready for that. Today we're going to be talking about standard form, okay? Standard form is our second linear equation. Now remember, a linear equation always has an x and a y. Okay, there's always an x and a y. That represents our point x comma y. Okay, so that is still true. That is still true between standard form and slope-intercept form. There is always going to be an x and a y. It is also always going to form a line, which makes sense because it's called linear equation. Okay, these are our two main similarities to standard form, slope-intercept form. Those are our main two similarities. Actually, what we're going to do right now is we're going to add a page. I know I like to improvise. I have it all planned out, and then I'm like, you know what, Molly, let's try this. Let's make a circle. Okay. And then let us make another one. Guess what's coming up? A Venn diagram. Yeah. Okay. And on this side, we're going to write slope-intercept form. And on this side, we're going to write standard form. Okay? And we're going to come back to this. But the one thing that we're going to eventually put in here is some of that. But we're going to come back to this. So don't miss this page yet. We're going to fill this in because it's really important that you have this page handy. Like I said, I don't want you confusing slope-intercept form and standard form because they're two very, very, very different. Okay, one of the things they have in common, we can fill in the center a little bit. And let's do, well, maybe I should have chosen like two different colors that can mix, but that's okay. Let's say that standard form and slope-intercept form both have an x and a y to make the point x comma y. Okay? And they both make a line. We can also plug in numbers to solve for missing variables. So like what we do when we're looking for x and we know what y is, we can plug y in to solve for x. Or what we're doing when we look for y, we can plug in an x to solve for y, okay? But you guys are probably like, all right, but this makes no sense to me because we have no idea what standard form is. So get to it, Miss Giambi, and I will. Let me just make this a little bit smaller in case we want to add things. We're going to add things throughout. Okay, going off script, guys. Okay, the first thing we need to talk about, last linear equation, slope-intercept form, we used the y-intercept a lot. The y-intercept was a very important part of slope-intercept form, and it still is, which actually we can add that here. We use the y-intercept in standard form, but we also use the x-intercept. The x-intercept is also very, very important in standard form. So what is the x-intercept? I'm going to guess that maybe you can figure it out. If we know what the y-intercept is, where the line crosses the y-axis, and it's 0, comma y, 0, comma b, I bet you can guess that the x-intercept is when y equals 0, and it's, I keep choosing the same colors, where the line crosses the x-axis. This is always x, comma 0. The x-intercept is when we have the x value. The y-intercept is when we have the y value. So it's where the line crosses the x-axis. You can see here my x-intercept is 5. So it's 5, comma 0. Here I even give you your y-intercept, the point where the line crosses the y-axis. You can see that we have the y value. Okay. 0, comma y, that's our y-intercept. And then here we have our x-intercept, the point where the line crosses the x-axis. And that is x, comma 0. So when we have one number and the other one is 0, the number that we have, it's that intercept. So if it's 0, comma 5, we have the y value, that's my y-intercept. If I have 8, comma 0, we have the 8 in our x value. And the other one's 0. That's our x-intercept. So let's look at a few examples. An example is 5, comma 0, negative 8, comma 0, 3.5, comma 0. You might be noticing a pattern. 44, comma 0, negative 10, comma 0. That pattern being, oh, interesting, I have that color chosen, which we can use that. Every y value is 0. So be very careful that you don't mistake the x and the y-intercept. When you notice there's a 0, look which one has a number that's not 0, and it's going to be that intercept. If it's the x value that's not a 0, it's your x-intercept. If it's the y value that's not a 0, that's your y-intercept. Some non-examples are 0, comma 9. This is actually a y-intercept. 12, comma 3, negative 5, comma 4, 0, comma 0.5. Again, another y-intercept. And 3, comma negative 16. So you can see the difference between a y-intercept and an x-intercept. You will always have a number. Now, there's only one point in the entire world that's both an x and a y-intercept, And that's our origin, because both x and y are 0. It's crossing both axes at the same time. That's why it is our origin. That's where they intersect. All right? So that is our only both x and y intercept. So hopefully you now understand what is an x-intercept. And we're going to look at why they are important in the real world. We know that y-intercepts are important because they're usually our starting point. So let's look at our y-intercept. When the line crosses the y-axis. Let's look at our graph. This says value of a computer. We have time in years as our independent variable. We have our value in total money as our dependent variable. My rate of change, or my slope, is y over x. So this means the value of a computer over the number of years. The total value of a computer over the number of years. All right? And the number of years that you own it. That's what this means. So when you buy a computer, the amount of time after having it, how much you could resell it for. Okay? So that's the graph that we're looking at right now. Our y-intercept is 0, 1,000. What do you think this means? If it's 0, 1,000. 0 number of years, 1,000 total dollars. I bet you're thinking to yourself right now, because you can't really speak to me, you're probably thinking that means that after 0 years, which means what? After 0 years, a brand new computer. A brand new computer values, or has a value, let's say that. Has a value of $1,000. Okay, so someone buys a computer for $1,000. That's their starting point. Now let's look at the x-intercept, where the line crosses the x-axis. This is 5, 0. What does this mean? Number of years, total value, total dollars. This means that after 5 years, the computer loses its value. Now, we know that we can always find someone somewhere to buy the computer from us, right? If we want to sell it, but we lose its total value. You could never sell it back to the store or etc. Okay, so after 5 years, it loses its total value. In the real world, usually the x-intercept kind of represents our end point. Maybe it's not necessarily our end point, but it's when our total equals 0. Okay, so it could go up after that for some reason, depending on the context, but it's usually kind of a crash. If we're at $0 or something like that, that's usually not a good thing. But that's why x-intercept is important, because businesses or whatever you're working for needs to look at that x-intercept, because a lot of times they don't want the x-intercept to happen. So, what is standard form? Well, I'm going to tell you right now. We know that when we look at slope-intercept form, which we're going to put up actually here in our Venn diagram, when we have slope-intercept form, just by looking, we can see the slope, which is our m, and y-intercept, which is our b. Okay, we know slope-intercept form is y equals mx plus b. Okay, so just by looking, we know the slope and we know the b. Ladies and gentlemen, in standard form, which I'll write in a second, just by looking, we are given no information. You're going to have to do some math when you see slope-intercept form. You are not able to look at it and just know information. That's why standard form, slope-intercept form is more commonly used and it's more popular because it's better. It gives us more information. Okay? It's like the queen of all equations. Standard form is kind of like the prince or the princess. Okay, it's equally as powerful and used and needed, but we don't use it as much because most people like slope-intercept form better. When we look at standard form, we are not given any information. So I'm going to write standard form here just so we have it, and then I'm going to scroll down. AX, actually, let's do it with capitals. Okay, so we're going to go down. What is standard form? Standard form is AX plus BY equals C. Okay? We know that X and Y are our X and Y point. That's in every linear equation. Ladies and gentlemen, this is huge. I don't know why the math world did this. This B is a capital B. And that's hugely important because this B does not represent our y-intercept. I don't know why they wouldn't use a different variable. I've never understood that. I've wanted to change it, but I don't feel like I can because it's math. You know, you can't really change it. So that's another really important thing to put in our standard form equation. I'll go back. I know, I'm sorry. I'm zooming through. The B in standard form is not the y-intercept. That is why it's capital. Okay? I know that's silly. I agree with you. Okay? But the B in standard form is not our y-intercept. It is just a random number. Okay? So just by looking, we're given no information, and the B in standard form, that B is not the y-intercept. So we have standard form AX plus BY equals C. Standard form, again, AX plus BY equals C. A is the coefficient of X. It is not the slope. M is the slope. Okay? So in this one, again, you don't get any information from looking. The coefficient of X here in standard form is not your slope. B is the coefficient of Y, not the y-intercept. Okay? And then they add together to make C the constant, which is also not your y-intercept. None of these things mean anything until we do math. Okay? None of these things mean anything until we do math. The only thing that means anything is this X and this Y can form together to make a point, X comma Y. Standard form, you have the x and the y are on the same side of the equal sign. Okay, the x and the y are on the same side of the equal sign. I'm going to tell you too right now, in this equation, x and y kind of have different jobs as independent and dependent variable. Okay, so that's another change. That's why I said you need to completely take your slope-intercept form box and put it to the side. Do not try to find connections between the two of them except for the ones that we're doing in our Venn diagram. Except for these ones. Okay? Because they're totally different. So we can put in here slope-intercept form. Just by looking, you can see the slope and the y-intercept. In this one, the b and the constant are the y-intercept, and the coefficient of x, m, is the slope. Here we can say, actually we can say x is independent variable, y is the dependent variable, and x and y are on two different sides of the equal sign. That's probably your biggest indicator of how to know whether your equation is written in standard form or slope-intercept form, where the x and y are. Here we have the coefficient of x means nothing. The coefficient, well, it means something in the terms of an equation of a real-world context, but we're going to do that next class. We're not going to do that this class. The coefficient of y means nothing. And our x and y aren't necessarily dependent or independent. They still are, because x is always independent, y is always dependent, but in the terms of a word problem, it's different. We're going to talk about that. X and y are on the same side of the equal sign. But don't worry too much about the independent dependent variable with standard form, okay? That we're going to talk more about next class, like I said, the next lesson at least, okay? So, some examples of things written in standard form. Well, we have ax plus by equals c. We have 3x plus 5y equals 9. Negative 2x minus 6y equals 3. We have negative 7x plus 4y equals 2. We have x plus y equals negative 4. And we have x minus 2y equals 15. Now, I'm going to highlight, this is a. We can find our a by looking at 3 is our a. Negative 2 is our a. Negative 7 is our a. Here is an invisible 1. Here is an invisible 1. Then we have b. Positive 5 is our b. Negative 6 is our b. Positive 4 is our b. Positive 1 is our b. Negative 2 is our b. And last but not least, we have equals c. C is 9. C is 3. C is 2. C is negative 4. C is 15. Some non-examples would be y equals mx plus b. That's slope-intercept form. Y equals 2x minus 4. That's slope-intercept form. The x and y are on two separate sides. 7x plus 5 equals y. Slope-intercept form. 4 plus 8 equals c. That's not standard form because there's no x and there's no y. So this is standard form. ax plus by equals c. So how do we graph an equation in standard form? Guys, I decided to show you like the mechanics of standard form before showing you when it's going to be used. Like I said, next class, we will talk about when the real world applications of standard form. And you're going to see actually how relevant it is. And actually, you're going to see some really interesting connections to your life. Okay, so standard form is very important. But first, I kind of want to get you comfortable with it. How do we graph an equation in standard form? By using the intercepts, which is x, 0, 0, y. Okay? In order to make a line, all we need is 2 points. All we need is 2 points. And so if we find the 2 intercepts, because we don't know what the other 2 points are, what any other point is, but if we find 2 intercepts, we can graph. We start, here is graphing in standard form the first way. There are multiple ways to graph standard form. That is another lesson, okay? That's probably going to be 4.4C, okay? So 4.4A is just talking about standard form. What is it? The first way of graphing. 4.4B is going to be the real world application of standard form, and 4.4C is going to be the second way to graph it, okay? I try to break it down so it's not too much information. So graphing standard form, the first thing we do is we find the x-intercept, okay, which is x, 0. We do that by plugging in 0 for y and solving for x. So let's look at an example here. If I have the equation 3x minus y equals 6, this is standard form. What I'm going to do is I'm going to use the point x, 0 because I know that y equals 0. Actually, we can leave that. So if I have 3x, instead of y, I'm going to plug in 0. And now I only have one variable left. I can solve for x. Well, I know plus I can either add 0 if I want. And I get 3x equaling 6. To get x by itself, I divide by 3. And I get x equals 2. So therefore, now I can have the point 2, 0. That is my first x-intercept. That's my first point, okay? Second, what we can do is we can find the y-intercept, which we know is 0, y. We can plug in 0 for x this time and solve for y. So let's look at that. This time we're going to use 0, y. We don't know what y is, but we do know that x equals 0. So when I have the equation, I can plug in 0 for x and do my railroads. This is 0 minus y equals 6, which is minus y equals 6. Remember, ladies and gentlemen, we can never, ever, ever leave a negative here. That's like a -1. So I divide by a -1, and I get y equals -6. So instead of 0, y, I get 0, -6. Now I have 2 points. I can graph those 2 points and draw a line between them. Okay, so if I had my graph, which I forgot to draw one, but that's okay. I can do this and just quickly draw one here. Okay, and I see that my x-intercept is 2, 0. My y-intercept is 0, -6. And now I can just take a line and I can draw it through both points to make my line. And there you have it. You've graphed your standard form, okay? So you find your x-intercept, and you plug in 0 for y to solve for x, you get 1 point. You find your y-intercept, you plug 0 in for x, and you get another point. And then you just graph those 2 points. So we're going to do 2 examples very quickly together, okay? So let's look at this one first. First, we need to find 0, y and x, 0. I like to always start by writing those 2. So then I know this one, x equals 0, and this one, y equals 0. So I'm going to take the equation 2x plus y equals 8, but instead of x, I'm going to replace it with 0, and I'm going to solve for y. 2 times 0 is 0, so y equals 8, which means this point then actually is 0, 8. Okay, so instead of y, I have now found that y equals 8. Okay, and then for this one, I know y equals 0, so I have 2x plus y equals 8. But this time, instead of y, I'm going to plug in what y equals, which is 0. And I solve for x. Well, 2x plus 0 is 2x equals 8. Divide by 2, divide by 2, x equals 4. So I know my point is 4, 0. Ladies and gentlemen, you can see that's my x, x, x. Never, ever, 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 ever write these as 4, 8. That is not the point. That is just 1 point, and you are mixing your x and y intercept. That is incorrect. You want 2 points. One that is your y-intercept. This one is your y-intercept, and one that is your x-intercept. They are never, ever combined. So now I graph 0, 8, 4, 0, and I can connect them with a line. Perfect. Easy peasy. This is now the equation 2x plus y equals 8. Like I said, today we're just going to do it where you practice and you learn about it. Next class, we'll start putting a little bit more meaning and contextual meaning to it, real world meaning. Why don't you try this one on your own? I'm going to pause the video because I'm going to keep going because I don't have much time. But pause the video and try it on your own. Go ahead. Okay, those of you that didn't pause, whatever, but I'm going to continue. So I know I want 0y and x 0. Okay, so this is where x equals 0. This is where y equals 0. So I have 3x minus 4y equals 12. But I know that x equals 0 here. So I'm going to erase and insert 0. So 0 minus 4y equals 12, minus 4y equals 12. Do not lose that negative sign. Divide by negative 4, divide by negative 4. I get y equals negative 3. So my point is 0, negative 3. That is my y-intercept. Then I, this time, know that my y is 0. So when I have 3x minus 4y equals negative 12, I know instead of y, I need to plug in 0. So I get 3x minus 0 equals negative 12. 3x equals negative 12. Divide by 3, x equals negative 4. So my point is negative 4, 0. I'm going to graph those 2 points. 0, negative 3, negative 4. Oh, I did that backwards. 0, negative 3, negative 4, 0. Be very careful because I just made that mistake too. Okay, be very careful that you don't mix up which point goes where. And there we go. Looking here, we can match the equations with its graph by finding the x and the y intercepts. Okay, so I can look and see for number 11. Number 11 is 15x minus 12y equals 60. If I want to look for x comma 0 and 0 comma y, I can plug in 0 for y. Oops. Equals 60. So it's 15x minus 0 equals 60, which is just 15x equals 60. I divide by 15, divide by 15. X equals 4. So that means that this point actually is 4 comma 0. Okay? Which I know rules out this one. Then I can go and I can find my y-intercept when x equals 0. So I'm going to plug in 15. Instead of x, I'm going to put 0 minus 12, y equals 60. 0 minus 12, y equals 60. Divide by negative 12. Y equals negative 5, which means this point is 0, negative 5. Which means this one represents 15x minus 12y equals 60. Okay, why don't you go ahead and try on your own number 12 and 13. Okay, 12 is either going to be A or C, and 13 is either going to be A or C. So go ahead and try that. Last but not least, here's your exit slip, ladies and gentlemen. This is what you will need to turn in. You are going to need to graph each equation in standard form using the x and y intercepts. Remember, the x-intercept is x comma 0. The y-intercept is 0 comma y. So you're just looking for those 2 points. If you need help, go back and rewatch this video. Rewatch me doing it here and do it side by side with me, but with the numbers from the exit slip. Or go back and do it from here with the steps. Read these steps to go through and do it. All right? I hope you had a wonderful, wonderful time during this video. I hope you learned a lot. Thank you for being amazing and following along. Have an excellent day.